Yes, hello students. Welcome to Arjun Mech classes. Today we solve one more problem on the LPP formulation. So we'll go through that. So we have a problem here. A manufacturer of furniture makes two products. So they are going to produce two products. The first product is chair and another product is table. The chairs and table. Processing of these two products done on two machines A and B. A chair requires 2 hours on the machine A and 6 hours on the machine B. And a table requires 5 hours on machine A and no time on the machine B. There are 16 hours of time per day available on the machine A and 30 hours are available on the machine B. The profit gained by the manufacturer from the chair and the table is rupees 1 and rupees 5 respectively. Formulate the LPP. So as we already discussed, so we need three components to formulate the LPP here. The first one is decision variable. So we have to identify the decision variables in this problem. So here we are having two decision variables. Those are two products developed from these two machines, right? So what I will do is I will write the statements here. Let x1 be the number of chairs produced and let x2 be the number of tables produced, right? So we got decision variables. Next work is what we have to identify the objective function of this problem. So objective function is what here? Objective function we have to write. So you can see here a profit gained by a manufacturer from the chair and the table is rupees 1 and rupees 5 respectively. So means he is in a profit. So the problem is subjected to what now? This problem, whenever the profit comes, the problem is subjected to what? Maximization, because always we look to increase the profit, not to reduce the profit. So we want to maximize the profit, right? So this problem is subjected to what? Maximization problem. So then the maximize z equal to x1 plus 5x2. This is our objective function. So next work is what? We have to identify the constraint equations. Constraint equations we have to write. So what are the constraint equations here? So you can see here he is having two products. He is producing those two products from the two machines, and those two machines are having the time limitations. Means we can use the machine A with a certain time, so we can use machine B with a certain time. So we are having a limitations. So means we are having two objective equations. One from the machine A, one from the machine B. You can see here for the machine A constraint we'll write here. For machine A, you can see the constraint here. So what is the constraint here? So from the machine A is producing a chair requires 2 hours on machine A. So from the machine A he is producing a chair here and it requires 2 hours. So then what I will do, chair is already given here. So you can see the x1 be the number of chairs produced. So means x1 is subjected to chair plus now machine A, again any products is producing here. You can see here a table requires 5 hours on the machine A. So again on the machine A is producing table and table is having the variable as x2. So then it is going to become 2x1 plus 5x2. So what is the limitation for this equation here? So he given for the machine A, the limitation he given already, you can see, and table, right? And machine B, there are 16 hours of time per day available on the machine A. So means on machine A, we want to use the machine A, he can utilize only up to 16 hours so per day. So 16 hours, beyond that he can't utilize that. So means he is having a limitation of 16 hours. So what I will do, so he can utilize only maximum of 16 hours, right? So for machine B you can write, for machine B, so machine B is having another limitation here, so we have to read that one. From the machine B he is going to produce, what is he is going to produce, and 6 hours on the machine B, the chair he is going to produce from the machine B here. So chair he is going to produce on machine B means it is going to become 6x1, 6x1. So then any other limitations he given, so here is given, and no time on the machine B he is telling, no time on the machine B, he is not producing table here, he is producing only chair from the machine B. So we have only one decision variable here, so that is x1 only, so 6x1, and it is having a time limit of what, 30 hours. So it is, he can utilize only this machine B for 30 hours. This is the second equation. So what I will do, I will write this as a second constraint, this as a first constraint, and we have a the non-negative eta conditions here, it should be x1 comma x2 should be greater than or equal to 0. Once we done this means, after this we have to represent this total problem in a box. Maximize z equal to x1 plus 5x2 subjected to constraints 2x1 plus 5x2 less than or equal to 16 and 6x1 less than or equal to 30, x1 comma x2 should be greater than or equal to 0. So this is the representation of LPP. Thank you.